Swayam Prabha. Digital India. Educated India.
Welcome to Lecture 3 of NPTEL video series on CAD. In the previous lectures, we have seen how forms of different products can be rendered and represented using a paper pen approach or a solid modeler. An inquisitive mind has also put forth the following queries. Question 1. How do solid modelers work? Question 2. What is the mathematics behind the graphics? Question 3. Can solids be generated efficiently? Question 4. Are solid modelers capable of modeling a complex solid? And finally, the fifth question. Is data storage or retrieval efficient? We'll start by refreshing briefly the procedure of form design. We'll then study some properties of solids in detail. We are still trying to perceive solids here. To refresh, the starting point in our design procedure is to figure out or come up with the functionality of a system or a component. One makes a wish list. One can also survey, talk, or ask a lot of people. The list can be as elaborate as possible, and then one can choose critical items for form generation. One can then come up with many forms satisfying a set of items chosen from the wish list. We know from the workshop that form design can be manual or automated. The manual approach goes with the conventional paper pen technique. Everyone has heard the phrase, back to the drawing board. One requires some a priori notion or idea as to how a product should look like. The manual approach involves creativity, skills, and experience of a designer. It, however, does not give a three-dimensional rendering of the form. In the automated method, one may not have much idea, but a rough notion about how a product should look like. One can only identify components and interrelation between them via a set of basic rules. Within these basic rules, a computer can then propose a candidate design, analyze it, and then modify it to make it better than the previous one. An example here would be the linkage generation near the end of lecture 1. Personally, this is how I differentiate between the conventional paper pen approach and the automated solid modeling or form design approach. The first one, or the paper pen approach, is like a typewriter, while the second one, or the CAD approach, is like a word processor. With the word processor, we have a lot of flexibility. We can change the matter anytime, anywhere in the document. It is very easy for us to correct errors. We don't see any wastage, such as that of paper. A word processor offers a lot of options for font size, font style, formatting, making tables, sketching pictures, and a lot more. In case of a typewriter, one needs to be skillful. The matter gets printed as one types. In case there are more than a few mistakes, paper gets wasted. There are not many options with regard to formatting. Note that typing or sketching may have their own advantages. Creative expression may still be at its best for someone who prefers conventional approach. Of course, one can print the document when done. Automated form design can be accomplished better if we assume that designs are modular. For example, those in nature. There are finitely many designs out there, all of which are composed of the 120 odd elements present on the earth. Human designs can be modular, though comprising of much less components. Question: how do we perceive solids? Solids are like geometric entities that occupy a finite volume in space. Solids must satisfy a set of properties on boundedness, on boundary and interior, on boundary determinism, homogeneous three-dimensionality, rigidity, and closure. Let's explore these properties in detail. Boundedness. A set V of points must occupy a finite volume in the Euclidean space. This slide shows three solids. Are they all valid? Yes, as they occupy a finite volume in space. Let us now take away the top face of the block and the top face of the cylinder. Are these now valid solids? No, because their respective volumes are not bounded anymore. Let's now try to understand the two terms, boundary and interior, for a solid. Let BV and IV be two subsets of V such that the union of BV and IV equals V. V is a set of all points that define a solid. BV is the set that comprises all boundary points. IV is the set of all interior points. A point P belonging to V is an interior point, that is, P belongs to IV if there exists an open ball enclosing P consisting of points in V only. Let's consider this solid here. IV is a set of all interior points. BV is the boundary of the solid, and the external space is the Euclidean space minus a set of all points defining this solid. This is ball B enclosing a point P, and the ball is of radius r. This is ball B1 as the boundary of the solid. Definition of an open ball. If P sub 0 is the center of the ball B and the ball is of radius r, and if P sub I is a point that belongs to the ball B, then the distance between Pi and the center of the ball should be strictly smaller than the ball radius. An open ball can be considered to be a sphere without the surface. All we say here is that a point P belongs to the interior of the solid if it is enclosed by an open ball of any non-zero radius r, such that the ball itself encloses all the interior points of the solid. Take the ball B1 for example, which encloses a boundary point. No matter where you place the ball to enclose the boundary point, it will always include some points of the external space, which is the Euclidean space minus V. A point P is a boundary point if P belongs to V and P does not belong to IV. Boundary determinism. Jordan's theorem for a two-dimensional Euclidean plane E2. This is a fundamental theorem that lays down the basis for solid modeling. A simple non-intersecting closed, which is also called the Jordan curve, divides plane E2 into regions interior and exterior to the curve. Take this picture for instance. C is a simple, closed, non-self-intersecting curve. C is dividing a set of all points on this plane into two subsets. One is IV, which is interior to the curve, and the second is EV, which is exterior to the curve. Formally, for C as a continuous, simple, closed curve in E2, complement of C in E2 has precisely two connected components, IV, which is the interior set and bounded, and EV, which is the exterior set and is unbounded. Here C forms the boundary for each set. For a pair of non-empty subsets U and V of the plane, U and V are connected if the intersection between the two subsets is a null set and the union of the two subsets is the entire plane itself. Let us divide a set of all points on C into two subsets, Ci and Ce. I here corresponds to the interior and E here corresponds to the exterior. Let us define the two subsets U and V as U equals IV plus Ci and V equals EV plus CE. Clearly then, we can see that the intersection between the two subsets is a null set because there is no common point between the two subsets IV and EV, and also no point is common between the two subsets Ci and Ce. On the other hand, if we consider the union between the two subsets, it is the entire plane itself, because what it is saying is we are taking the union of the set of all points in IV, the set of all points in EV, and also the set of all points on this curve. Boundary determinism again. This is the extended Jordan's theorem. Equivalently, in the Euclidean space, a simple and orientable closed surface BV divides a solid V into the interior, which is IV, and the exterior, which is EV spaces. We will come to what are orientable surfaces later. If the closed surface BV of a solid V is known, the interior IV of the solid V is unambiguously determined. This gives us a nice clue that solids should be represented and stored as simple, closed, and orientable surfaces, as opposed to a set of all points which are confined in space. For example, a sphere. If a spherical surface is known, so will be the sphere. Homogeneous three-dimensionality. A solid set V must not have disconnected or dangling subsets. As such, sets defy boundary determinism above. Take a look at this example. A block, we have a dangling surface, and also we have a dangling line. Question: is this a valid solid? No. Loosely, the block is of dimension 3, the plane has dimensionality 2, and the line is one-dimensional. A solid needs to be homogeneously three-dimensional. Rigidity. The relative positions between any 2 points P1 and P2 in V must be invariant to repositioning or reorientation of the solid in the Euclidean space. What we want to say here is that a solid may not be elastic in nature when subjected to rigid body repositioning. Take a look at this example. This is the initial position of the solid, which undergoes rigid body transformation and attains a final position here. A deforming body under any rigid body transformation, like translation, rotation, or the combination, is not allowed. Closure. Any set operation, which is union, intersection, or subtraction, when applied to solids V1 and V2, must yield a solid V3 that satisfies all the above previous properties. Consider this solid as V1 and this solid as V2. The relative positions between these solids can be any. Solid V2 can sit over solid V1. It can get inside anywhere. All I am saying here is this would be a bounded set of points, and this would be again a bounded set of points. If I want to manipulate the positions and combine these two solids in any way, be it the union, be it the intersection, be it their addition or subtraction, the resultant set should be bounded, and that is what would be a valid solid again. For example, if I add the points in solid V1 with those in solid V2, I get a new set V3, which is equal to V1 plus V2. The set of points V3 should satisfy all the previous properties we have discussed on solids. This gives us a vital clue. Set operations may be used to arrange components or solids. Let's consider a few examples. The first one is of that of a cube. A cube has 6 faces, 8 vertices, and 12 edges. Six faces make a simple, closed, and orientable surface. We'll try to figure what orientable surfaces are later. 6 faces are like patches comprising a closed surface. The second example, a sphere. A simple, closed, and orientable spherical surface represents a solid sphere. The third example, a torus. Again, a simple, closed, and orientable toroidal surface represents a donut. This is an example of an invalid solid. It has 7 faces, 6 for the cube and the one dangling. It does not form a closed surface. It defies homogeneous three-dimensionality, and therefore it does not represent a valid solid. In summary, a simple closed and orientable surface is good enough to represent a solid. One need not store a set V of points because there will be infinitely many, and they would cause storage problems. The set operations to design new solids will be slow, and solid modeling software will be slow overall. Now let's take a look at the results from the design workshop that the students did in lecture 2. So this is the first design. What we'll do is we are going to be looking at all the designs that the students have come up with, and we are going to be evaluating those designs as well as describing how the functionalities that you had initially chosen are all incorporated in your design. Okay, so let's do that. Group 1. So this is the first design of group 1. So group 1, design 1. This is the first form, I believe, of the first group. Different views. Okay, so let's go back, and this seems the best view that can help you describe all the functionalities. So can any one of you come up over here and describe the functionalities or describe the functions that were there?
So this is the table lamp. This lamp is with flap facility, and this can be folded into this place, and this will make this whole thing compact.
Okay.
And there the other functionalities also added with this table lamp. There is one display, and there we can see the timings, and we can also incorporate there reminder and global times, all those facilities we have chosen earlier. And there in the front panel also you can see some switches that will help us for doing all these things. And there are two holes as we can see in the top, and these two are for pen stand. And at the rear side of this table lamp there is one speaker that we are going to use for the FM that we have incorporated in our design. And at the back side there in the base there is the battery for backup, and there we also incorporated that for the charger facility.
Is this lamp battery based, or you have to have a electric cable?
Both, sir.
Electric cable.
Both, sir.
Okay. Did you also have a mobile charger in here, or maybe not?
Yes, sir. Yes, sir. That is on the back side. Back side, electrical panels and all these connections are going to be at the back side.
The rear side, you mean?
Yes, sir. Rear side.
Okay. Okay. Let's see if we. This is the back side that we have.
No, sir. That at the right, it is at the right side, right of this. There.
There?
There, sir.
Okay. All right. Thank you. Enough for you to evaluate this design? So remember, the students are still competing with their designs. So each student group is going to be evaluating all the other designs, the designs that they have not made. Anybody who would want to describe the second design, which we show now? So they had come up with the second form. Let's take a look at all the views.
So as we can see that these are the speakers. This thing is the LCD display in which we can see the global times, and it will also act as the reminder. This lamp shade contains the CFL tube and also the night lamp.
Okay.
And these are the various buttons we can say to operate the lamp. And on the back side or on the rear side we have the mobile charger, and inside the lamp.
Can we see that?
No, so that view.
Let's see. Here, maybe?
So this is the front view.
Okay.
And so
No?
rear view has not been shown.
Okay, okay.
But that contains the mobile charger point.
Okay.
And inside the body of the lamp we have the battery, which will act as an emergency backup.
Okay. Is that it?
Yes.
Okay. Alright, so you have everything for design 1. So why don't you go ahead and record your marks for the first 2 designs. You can take your seat. Any reason why you went directly for solid modeling as opposed to designing or getting your forms using the paper pen approach?
So initially we had made the sketches, but we were not able to show all the functionalities in it. That is why we directly went for solid model.
Okay. So it gave you bought time to be able to think and design your table lamps?
Yes.
Are you guys done? Group 2, they could come up with only one design. This is the first view of the design. The second view. The third view, completely folded and resting over the table, I believe. The fourth view. Which view would you want to choose to describe your design? Okay, would you like to describe all the functions? Would you like to acknowledge any help that you had taken from anybody when designing this?
Yes, I have taken help to make this in software by MDes student.
What's his
second
name?
year, Atul Sultani.
Atul Sultani. Okay.
Okay. Here we have used this lamp, which is very stylish, which our first criteria was. And here we have mentioned you the calculator part.
You can take some time to find the mouse on the screen and then start pointing at different functions. Yeah.
Okay. Here we mention the calculator, which can give us time, and alarm also. And FM part is also here, which we can control by these keys. And this is also foldable. And if we will see the another view of this, then we can assure that.
Let's see
Uh,
here.
this view. Then here, this is the glass. If we on the light, then it can be work as a night lamp. And there's a
Okay.
This is
Okay. Okay.
and here are the pencil and pen stand which we have mentioned.
Mhm.
And in the back of this lamp, we can use it as a mobile charger also.
At the back, let's try to find the view out.
I
Here?
think it is not here, sir.
It's not there.
No, sir.
Okay.
And we have also given the chargeable battery here so that we can use in the case of power cut.
Do you think this design of yours is going to be stable enough? Because your base seems to be a little smaller.
Yes, sir. It is stable
It-
because the
It's not going to topple.
No,
Is it going to topple? It's going to be resting on the table
yes,
properly.
sir, definitely.
Actually,
Because
we are
we,
using here LED bulbs.
LED bulbs for what?
So for lighting.
Would you like to?
So for the compact purpose of the lamp, we have used here LED bulbs, so that the size of the lamp can be compacted.
and because of the chargeable battery at the down, the center of gravity going to shift downward. That's why it is not going to.
Oh, it's heavy. The battery is heavy.
Battery is heavy.
Okay.
That's why.
Okay. Okay. All right. So this is what we have from group 2. Take a while and jot down your evaluation of this design. If the lamp is going to be working, it's going to be seen like this, maybe. Yeah. So you have this nice light on the table downward. Could you get that effect in the solid modeling software?
Yes.
SolidWorks? Is that what you use? Are you done?
Yes.
Okay, so we now see what group 3 has for us. Would anybody want to, the first design? So this is the design from group 3. Let me show different views first. Let me show different views. Okay, so which view would you like to choose to describe your functions?
So other one,
This one?
this one. Yes.
Okay.
So this is the very simple form of the study lamp, and here actually at the bottom we can see there is an aquarium,
Mhm.
And this is the flower pot, and
Okay.
we can use this for decoration of the room.
Okay.
And also here we can see that this is calculator,
Uh-huh.
and this is the simply study lamp, and inside we can use bulb, and there is an arrangement of only bulb.
Uh-huh.
And uh, this is back side here.
Uh-huh.
There is an arrangement of battery also, but we can't use this battery arrangement for aquarium. For
Okay.
there is only arrangement of electricity supply,
Okay.
and battery is used for only light supply to this.
Okay.
That's it.
Okay. Anything else that you want
No, sir.
to,
That's,
you would want to add?
no, sir. That's it. This is the very simple form of the study lamp.
Okay.
This
Any reason why you didn't go for a paper pen approach?
Sir, actually this is the very simple form, and paperwork will take only lot of time, and we can simply draw it on the by solid modeling.
Okay.
So that's why we didn't go for the paperwork.
Any particular reason why you chose this particular texture of your design?
Sir, because all the purposes are going to complete, because we are using calculation.
The texture, by texture I mean those little tile-like things, the rock-like things that you see there.
Sir, just to show that this is aquarium, I
Oh, okay.
show this.
Okay.
Just to differentiate from this base,
Okay.
I choose that.
So it's going to be of glass.
Yeah.
Okay. Okay, so this is what group 3 has for us. If you can go ahead and evaluate the design. Okay, so finally group 4, they have 2 designs for us. Let's take a look at them first. In the meantime, one of the members of group 4 can take the chair over there. Okay, so this is the first design from group 4. Let me show you different views of this design before the member from group 4 discusses. Okay, so which design would you like to choose? Which view would you like to choose to?
First,
The first one?
yeah. It is, yes,
This one?
yeah,
Okay.
yes, okay.
Yeah.
This is only in the decoration purpose as well as a table lamp.
Mhm.
We use the sound box is there. This is the sound box system,
Mhm.
and this is the 2.1 system is there, and
What is the 2.1 system?
2.1 music system.
Okay, 2.1.
Okay, yeah, and there is the various type of light is assembled here,
Uh-huh.
which all the parts can be rotated to around and twisting all the parts as you wish, and there are many features is established in this box like alarm clock, mobile charger. It is not be shown there, but it can be sufficient space there which can be assembled there,
So all your functions are at the base.
not base in the middle part of the
Middle part would be where? Can you show that on screen?
this part.
Oh, okay.
This is the channel and this is the buffer, and this is the supporting lamp. In this part also a bulb is stable,
Uh-huh.
and
So how many lights have you shown?
there is only one light which will all the direction it will be shown.
Okay, and what are the other hanging features?
Yeah.
Are they also lights?
Yeah, all parts give the lights because you
And
can
are these cups rotatable? I mean, can you rotate them
yeah,
in
it will
different
twist,
directions?
it can be twisted
Uh-huh.
in any direction.
Okay.
And all the system is rotated around this base.
So you have cylindrical
Yeah,
shaped
cylindrical shape,
shades,
yeah.
and then block shaped
Yeah,
shades, conical.
Yeah, all
Okay.
the type of light.
Okay, okay. Any reason why you didn't go for a paper pen approach?
Yeah, initially we got for the paper pen approach, but when we are going to the designing, so many description are be found in between designing this modeling.
Okay, so this is a little modified version of what you actually had
Yeah.
in your initial form design
Yeah.
exercise.
Yeah,
Okay, so this is the second design. So this is the first form
not this,
and the second form here.
yeah.
Okay,
Okay.
yeah. So Arun can come and which view would you like to choose to describe your design?
First,
This one? Okay.
actually this is the second design,
Uh-huh.
and this is all same features as first. This is the two speakers, and this is the tape record, and here it is a switchboard for all things.
Uh-huh.
And here this in second view we can see this is the watch,
Okay.
and these all lights we can rotate 360 degrees.
Okay.
Yes sir, that's it.
Pen stands, mobile chargers. I thought you had them in
Yes,
your.
yes sir. In first view we can see all.
Okay.
Yes sir. Here we can have the all in this switchboard.
Okay.
This is
Okay.
here we can have this charging board, all things.
Okay. Okay. So go ahead and evaluate the two designs that they have. Okay. So this is the first design from group 1. Okay. So group 2, how would you evaluate this design?
So for this, we have given 8 marks.
8 marks. Group 3?
So 9.
9. So these are out of 10 marks. Group 4? 8? 7.5? This is the second form from group 1. Group 4, how do you evaluate this?
8.5.
8.5.
So 9 marks.
9. Group 2?
6.5.
6.5. 8 and 9, 17. 17 and 7.5 is 24.5. 6.5 and 9 is 15.5. 15.5 and 8.5. This is 15. 15 and 9, 24. This is the design from group 2. Group 1, how will you evaluate the marks?
So 6.5 marks.
6.5. Group 3,
So 10 marks.
group 3 goes for 10. Group 4,
8.5.
8.5. This was how much? 25?
25.
This is the form from group 3. Group 4, how would you evaluate this?
9.
Group 4 goes for 9. Group 2,
6.5.
Group 2 goes for 6.5. Group 1,
So 7 points.
7.0. 9 and 7, 16. 22.5. This is the first form from group 2. Group 1, how would you evaluate this design?
So we have given 6 marks.
6. Group 2,
So 6 marks.
6. Group 3,
So 9.
9. And this is the second of the two designs. Group 3, what do you say about this?
So 9.
9 marks. Group 2,
So 6.5.
6.5. Group 1,
So 7.
7.0. 12 and 9 is 21. And 7 and 9 is 16. 22.5. So remember, initially we had started this entire workshop in the cooperative competitive mode. So the groups, 2 in a single group, cooperated together to come up with various forms of table lamps, and the same of you guys competed and evaluated all the designs that you just saw, based on which these are the final evaluations. Looks like this one tops the list. And the design from group 1, the first design from group 1 misses by a whisker, by 0.5 marks. And the third design is again from group 1. So this is number 1, this is number 2, and this is number 3. So this design from group 2 has topped the list. So what did you like about this design in particular?
So basically we evaluated every design based on 3 criteria: functionality, style and compactness. So this design scored mainly in style and functionality.
Okay, good. Group 3, what did you like about this design?
Sir, basically, sir, this design is very much compact and also stylish. That's why we are rating this.
Okay.
So we can use it anywhere. Actually, it is very compact and it is very stylish also. So we can use it anywhere.
Okay.
So
Not only for the purpose of study lamp,
study,
but
yes,
anywhere
sir.
else.
And night lamp also we can use it anywhere.
Okay. Group 4.
This is a stylish, not so much functionality, but it is so stylish, so we give the marks.
Okay. Good. This is the first design from group 1 that came second. What did you like about this in particular?
So it contains many features and it can be folded also. So we give the marks.
What did you not like about this design?
So not so much stylish.
Okay, so it lost in style.
Yes, sir.
Okay.
So I would like to say that if I am a consumer, then I would like to buy this because of the foldable, because it is foldable and lots of features.
Okay.
This is the main criteria of our design also.
Okay. Group 3.
Sir,
Why liked and why disliked?
So actually the main thing is that this sliding feature it is having, and the most attracting thing in this actually it is differentiating from other one, that the main thing this sliding, and also it is having a lot of features in this. That's why we like this.
Okay. Group 4. Why liked and why disliked?
Actually, it have more functionalities, and we can foldable. That is the main idea. We can movable.
And we dislike because it is a old design.
Old design?
Yeah.
Okay.
So we,
Do you want to suggest any modification to this?
yes, if base should be wrong in the should be some different designs.
Any modification particular?
Yeah, should be some curve should be there.
Some curve should be
Yeah,
there.
yeah.
Okay. Any modification that you would want to suggest?
So the base can be very compact. We can use as a more compact. We can made it more compact. The base.
You can make it more compact.
Yes, sir. And also that, sir, this design, sir, this holding the bulb, we can use it also very small, so it can be used as a compact design also.
Okay. Any modification that you would suggest?
No, sir, it is okay.
It is okay.
Yes, sir.
So,
Good.
but it lacks in somewhat in styling and compactness.
It lacks style a little bit and compactness a little bit. Okay. This is the design from group 3. Members of group 1, what do you think is missing here?
So basically it is a very large design. A table lamp should be such that it should occupy less space on the table. That is why we do not approve of this design so much.
Okay. Group 2, what do you have to say about this design?
So same thing. This is not a compact design and
It's bulky.
it's bulky. And what I think is, it if you use this lamp in your table, then it gonna occupy your more space. So you need a bigger table to accommodate this thing.
Okay. Group 4, what do you have to say about this?
It is very good design. I think it is some different design as we have seen.
It's a different design.
Yeah.
Okay. Do you still suggest any modification?
No, it is very good.
It is very good in your
I
opinion.
can suggest, but it is, if it is a compact, it is actually we are designing a table lamp, no? But it is somewhat bulky. If it is a compact, it is so better.
Okay, so you would want to go for compactness.
Yes.
Okay. Group 2, any modification that you would want to suggest to this?
It's the same thing, compactness.
Okay. Group 1, should be a little more compact or something else?
Yes, sir, it needs to be smaller, and aquarium really is not required for a table lamp. That is why.
Just a different idea, that's all. It's a new one.
But it occupies.
Maybe may not be that new, but
it still occupies a lot of space.
So maybe the whole base can be used as a table for this lamp.
okay.
Yes.
Then the aquarium will means maybe the stand of this table, and then if the light goes on the table, then it will look better.
Okay. So you want the entire table base to be the aquarium.
Yes, sir.
Okay. And it should be a sturdy aquarium so that it doesn't break.
Yes, sir.
Okay. Okay. Good. This is the first design of group 4. Any modifications that you would want to suggest to this?
So again, it is a very large design. There are a number of lamps which are not really required. The design is really good. On this style front, it is good, but functionality based, it is really not up to the mark.
Okay. Group 2.
So the same thing, the functionality is not so much,
Missing is-
and the lights, there are so many lights, and I think there's no utilization of that. And the bulkiness is also a criteria that it
There is
is
no
so.
compactness, and the design is very much complicated.
I think it is not fitted for all the tables.
Okay. So you think it's not more of a table lamp? It's not that much of a table lamp, but more of a lamp,
Yes.
of a side lamp or something.
Yes, sir.
Okay. Group 3.
So it looks like good, but it's somewhat heavy. It can occupy somewhat larger space.
Okay.
It could be somewhat compact.
Okay.
Sir, it is very bulky actually. It is very stylish, but from the point of functionality, it is not that much good. But yeah, of course, it is unique in its own style.
Unique in own style.
Yes, sir.
Okay. Do you say the same thing about this design from
Yes,
the
sir.
same group?
Yes, sir. Same thing, sir.
Okay. How about you?
So the same thing.
Same things.
Bulky? More of a side lamp as opposed to a table lamp?
Yes,
Yes,
sir.
sir.
Yes, sir, again, the number of lights that have been provided, they are really not required, because table lamp should be such that they should be focused on one particular area. So again, there is some modification is required in this.
Okay. So as you know, different designers have different views when it comes to designing different products. Let's see what students learned from this entire workshop. Group 1, what did you learn from this workshop?
So basically, we learned how to mix aesthetics with functionality. That is the main thing that we achieved.
Okay.
Sir, we have just learned how to go through all the procedures, how we can design a form that we are desired to make, and that functionalities how to incorporate in the design, that we have learned through a procedure.
Okay. Group 2, what did you learn?
So we have learned that how to design a thing, or how to design anything step by step, and we have also learned that this conventional paper pen approach is far more behind from today's technology. In today's world, you can use various CAD software.
That is of course your opinion, right? I mean,
Yes.
I'm not saying that. That's
Yes, sir, maybe.
Okay, that's your opinion.
Yes.
Okay. I would still, so if I'm going to be designing something, I would still use a paper pen approach.
So, but the basic thing is when you start from point 1, then first you have to follow the paper pen approach itself.
Okay.
Because
so-
you have to list up all your functions and what things you are gonna incorporate in them.
Okay.
So there you need the paper pen approach itself.
Okay.
So I learned that how to design an object, and I also
Product.
how to design a product, and also learn that different people have different mentality and different requirement. According to that, they have made design. So if we combine all the design and think combinedly, then we will have definitely one of the best design.
Okay.
That I learned.
Okay. What did you learn from
Sir-
this workshop?
So I have learned how the craziest idea can come in mind for a particular type of product, and how can we incorporate into a reality.
Okay. What did you learn?
So actually, I learned that different mind came with different designs. So a lot of uniqueness came into this. So we have designed only from one point of view. So different views can also come in our mind. We don't think about this. So we can design. We can combine all these and design such a good product.
Okay. Can you think? Do you say that you can come up now with a lot better design for a table lamp?
Yes, sir. Of course.
You would?
Yes, sir.
Okay. Group 4, what have you learned?
Actually, I learned the creativity of the whole. For a single table lamp, we can see the different types of creativities. And in the real practice, we are going to like this only. I think from brainstorming and for the design any product, we have to take some steps. I learned the steps in this workshop.
What did you learn?
I learned that how many designs will be there in a single table lamp, and I think different type of ideas should not be there.
Different types of ideas should not be there?
Yeah, because if you think about a table lamp, it will consider about only a table lamp, and if you create something new, it will be not be good.
Okay. So something new is something that you would
not be
approve of.
acceptable by most of them.
Not necessarily.
Yeah.
I mean, it will be. It will take time, but it will be eventually.
Maybe.
Okay. So you hold a little pessimistic view at this time, but that's okay. I mean, don't get disheartened, but that's okay. Would you want to suggest any other design procedure, if you can think of? As I said before, that there is no set of rules in particular in designing anything. Would you like to suggest any other design procedure? Or this is just fine?
This looks good, but like instead of having competing with each other, we could have worked together and come up with one better design than all of these.
Okay, let's try that some other time, but definitely we'll try that. Okay, so you'd like to let go of the competitive spirit and cooperate amongst yourselves.
Yes.
Okay.
But sir, maybe after that, what you say, in post processing, we can compile up and we can go for a better design.
Okay.
That's okay. But competitive spirit, I think that's fine.
Okay. So you approve of the competitive spirit.
Yes, sir.
Okay. So would you like to suggest an alternative design process, or this is good for you?
So I think this is good for a competitive type of venture.
Okay. So the 7 steps that we executed in the workshop, are they okay, or would you want to suggest another step?
So I think this is okay.
So, but I want to combine all this, the style of group 4 and compactness of group 2 and the functionality of group 1 and the naturality of our so I want to combine all this and want to design such very unique design.
Okay. Group 4?
I think this is the better procedure to follow.
Well, I mean, this is the only procedure that we are following. I mean, you don't know of any other procedure that may be better than this?
No, sir. That survey, before going to the design, we can go to the survey, what is existing.
Okay.
I think better than that, the crazy things we can come from this procedure.
Okay.
I think this is the better.
You like crazy?
Yes.